Ripple tank is a specialized water tank that is used to study general wave properties. These include reflection, refraction, diffraction, and interference between water waves. The instrument itself is made up of many different components, which we will consider individually. At the top of the ripple tank is an overhead light. This is used to shine light on the below water tank. The water ripples then appear in a set pattern, which is later observed on a screen. We then have the shallow water tank. This tank contains a certain amount of water through which the waves are generated. Note, the bottom of this tank is transparent, which allows the light to pass through and pattern to be observed on the screen. Next, we have the oscillating paddle, which is connected to our power supply. In this case, the oscillating paddle is connected to two spherical dippers, but it can be a planar dipper as well. As the paddle oscillates, it moves up and down, creating disturbances on the water surface. These disturbances travel in form of water waves from the center outwards. Lastly, we have the power source. The power source is used not just to provide power, but regulate the intensity of overhead light and control the variable speed of the ripple motor. We see a functioning ripple tank. The motor is turned on, which in turn causes the wooden paddle to oscillate up and down. As the wooden paddle oscillates, it causes disturbances on the water surface, which travels as water waves. We see a definite pattern below, with dark and bright regions. The bright region corresponds to crust in water wave, a point where water molecules are at their highest, while the dark region corresponds to trough in water wave, a point where water molecules are at their lowest. Now let us consider how different dippers create different type of water ripples in the tank. If we use a spherical dipper, then circular water ripples appear. They radiate out from the center to the edge of the ripple tank. If we look at the three-dimensional model, then we get a clear picture. The origin or center point is the position where the spherical dipper moves up and down, disturbing the water surface. If a rectangular shaped dipper is used, then planar water ripples appear. These ripples start from the source of disturbance and gradually spread throughout the ripple tank. If we look at the three-dimensional model, then we get a clearer picture. We can see concentric bright and dark regions. These represent regions of crust and trough, water particles at their highest and water particles at their lowest. Consider a spherical dipper creating circular water waves. These waves radiate from the source and move outwards. Now, if these waves strike a barrier, a change in direction of these waves occur. The angle with which these waves strike is equal to the angle by which they are reflected. We get a clearer picture in three-dimensional figure. This change in direction upon hitting a barrier is known as reflection of waves. Ripple tank is used to study this characteristic, and we will discuss it in greater depth later. In this case, we see water ripples moving from green region to the blue region. As they transition between the two regions, we can see that the waves become closer. Moreover, they appear to slow down. We can also assess this in the three-dimensional model. As the waves move from one region to another, they experience a change in their speed and wavelength. This is called refraction, and we will consider this in greater detail in later sections of this chapter. When waves come across a barrier with a small opening, they spread outwards, as you can see. This phenomenon is known as diffraction and will be considered in more depth in your advanced level studies. If the size of the opening is increased, more of the waves can pass through, and these waves have the ability to interfere with each other. This is known as interference, and if we place a screen, we can see a pattern on it, marked by the red region. If we use two opening instead of one, we get a more diverse interference pattern. Thankfully, the consideration of these patterns is beyond the scope of ordinary level.